Here we have 8 different powers of I, and we want to say what they're equal to. Now it says from the pattern on exercise 4, and that should actually say exercise 5 here, simplify each of the following powers of I. So just as a reminder, I'll move this down a little bit and create some space up here, which you guys should have some. The 4 base powers are I to the 0, and actually I want to write this in a column, so let me erase that. So I to the 0, which equals 1, I to the first, which equals just I squared, which equals -1, and I to the third, which equals -I. Now, if you look at this, there's 4 steps on the pattern, and that's going to be important. Something else I notice is that when the exponent is odd, I do have the I, right? For I to the first, I to the third. If we look back at our chart, I to the fifth, I to the seventh. If the exponent is even, the I goes away, and we just have 1 or -1. Now that helps me decide if the I is there, but the way we can decide about the negative sign has to do with thinking about remainders and what's left over if I divide by 4. So each time I go through this pattern, right, I have 4 stops along the way. So if I had, for example, I to the 29th, I would go through this pattern, kind of circling through it, 1, 2, 3, 4, 5, and each of these is like I'm going down the pattern, 6, 7 times, because 4 goes into 29 7 times, but I still have 1 left over. So that means after the 7th time, I would end up here because of that 1 left over. I wouldn't get through the pattern again, and ultimately, these 7 arrows I drew straight down don't matter. It's which one I ended on. So the way we can do that is if we take 29 and divide it by 4, and there's always a question, do you always divide by 4? And the answer is yeah, right? There's 4 stops along here. There's not 5 or 6, so we're always dividing by 4. So that goes in 7 times, right? 4 goes into 29 7 times. If I subtract, right, we write 4 times 7 below, and I have remainder 1. So whatever is this leftover is where that horizontal arrow is drawn, right? And that tells me the power. So if I got 1, this equals I to the first. Looking at my little table, I to the first is just I. So that's my answer. So you can do this in your head. So I'm going to say this once, but I'm going to show the division for the top row, and then I'll just talk about it on the bottom row. So one time, if you realize you can do this in your head, when I see letter A, it's I to the 38th. Now, if I think about what number, how many times 4 goes into 38, that's 9 times. 4 times 9 is 36, so I'd have 2 left over. So this one does equal I squared, which is -1. So you can see you can do these in your head. I'm going to show what work you can also show. Now you need to ask your actual teacher how much work they need to see. I'm actually okay if you don't show the division and do it in your head, but here is the division. So we're always dividing by 4. That goes in 9 times, and I subtract, and that gives me my power that it's equal to. So I to the 38th equals I squared. And looking at my pattern, I squared is -1. So the work that I require is just writing this breakdown. I make you write the smaller power of I, so I squared, and then what the answer is. But the red division below, that's not required. I'm going to show division on the next few just because some people do need to divide. It kind of matters how good you are with your factors. So 21 divided by 4 goes in 5 times, and my remainder is 1. So this equals I to the first, which on my chart is I. And it's nice to memorize these 4. That's definitely something, you talk about memorizing your multiplication facts. Knowing the first 4 powers of I so you can find all the other ones is definitely important. So the next one, I divide 83 by 4. That goes in twice. We subtract, this is that long division algorithm from going back to probably 4th grade. Goes in 0 times. So my remainder is 3. So this equals, I'm just going to draw a line so it doesn't get messy, I cubed, which is from my chart negative I, from right up here. Now, if you don't, you can't, even if in your head you can go from I to the 83rd to negative I, in my classes, and this is Mrs. Sauer talking, you can't, you have to write that middle I cubed just to show work. Next one, and this is the last one, I'm going to show division. And we know that, right, 4 goes into 40 10 times. There's a remainder of 0. So this one equals I to the 0, which is 1. So these are my final answers. I'm just going to circle them down the line. And now I'm going to do the next ones without. So I to the 51st, if I know that 4 goes into 48, that would be a remainder of 3 left over. So that's negative I. I to the 30th, I know that 4 goes into 7, so I'd have 2 left over. So that's negative 1. I'm going to erase a little bit for the next one. I to the 25th, 4 goes into 24, so I have 1 left over. So I have just I. And this one, a little bit more erasing. Zeros out of the way. I to the 36, 4 goes evenly into 36, so I have I to the 0, which is just 1. So that's the process, that's the minimal amount of work. And now we're just going to look at one applied problem that's a little bit trickier, but the same type of concepts. So here I have, which is equivalent to 5i to the 16th, 3i to the 20th, or plus 3i to the 23rd, plus I to the 26th. So remember, other than when we simplify with those exponents, we can think of I as x in terms of the way it behaves. So I can't add these together because my exponents don't match. If I had x to the 16th plus x to the 23rd, we couldn't add those together, so I can't add together here. So what I'm going to do is on the side, I need to simplify each of those powers of I like we did up top. I am going to do it the faster way. 4 goes into 16 evenly, so this is I to the 0, which is 1. 4 goes into 20, so I would have a remainder 3 with 23. So that's negative I. 4 goes into 24, so I have a remainder of 2 when it's 26. So that's negative 1. And these values, these answers, just came from that 4-step chart up top. So plugging those values in, I have 5 times 1 plus 3 times negative I. Now that parentheses is important. It's not 3 minus I. This is 3 times I to the 23rd, so this is 3 times negative I. And then plus a negative 1. So this is 5. This is a negative 1i, so 3 times negative 1 is negative 3. And then I minus 1. So we can combine like terms now. That's 4 minus 3i.